This next exercise, we're going to make agarose gel to examine the plasmid DNA we have isolated last week. The materials we need first is the microwave, which you can find on the side benches inside your lab classroom. Then a 250 ml flask, a 500 ml flask, the balance, whey paper, gel green, which you don't need at the moment as your instructor will bring it to you. Just raise your hand when you're ready for it. The gel tray, 50x TA buffer, deionized water, which you should be able to find by a sink in this kind of carboy that should write deionized water, 100 ml graduated cylinder, something that looks like this called a gel caster, which should be shared by 4 students. So 2 pairs should share 1 gel caster, and then 1 to 8 tooth comb. Okay, these are the materials needed. Working as a pair, but along with the other pair across from you, we're going to do step 1. And the goal is we want to pour agarose gel, which provides the matrix to allow the separation of DNA fragment. First, we want to put both gel trays. So this is your gel tray. You can put it in here, but you'll make sure that the group that's across from you also have their gel tray in there, because both needs to be in before you move this and then turn the knob to lock it really in. So the idea is you want the rubber seal to really seal the side, so when you pour liquid in, it won't flow out. So seal it tight, and then you want 2 gel trays in there. Unless there isn't another group across from you, then there will be just yours. But as a pair, you're doing 1. This is supposed to be the other pairs. So I'm going to cast 1, okay? Step 2, place a 8 tooth comb in the notches at one end. So do you see these notches? There are these holes, and there are these kind of notches that will fit in. So make sure it's in and tight. You don't want it to be sliding around. You don't want it like very much on the end. You want it in the notches. Okay, now step 3, we're going to make 350 ml of 1xTAE buffer. So how do we make that? We know we have a concentrated called 50x, which is 50 times more concentrated, this TAE buffer. And we want to make it into just 1x, which means the working concentration. And we want that in a 500 ml flask. However, to measure it out accurately, we're going to use a graduated cylinder. So the first step is we'll need 7 mils of this, and then diluted it into a total of 350 ml is going to give us 1x. Okay, so we're going to take 7 mils. Do you remember how to do this? You're going to dial your P1000 to 100, which gives you 1 mil, because it's 1,000 is 1 mil. 1,000 microliter, 1 mil, and you're going to do this 7 times. So 1, 2, 3, 4, 5, 6, 7. Okay, 7 mils in there. And then you're going to fill the rest with water up to 100 mil. So you're going to go over to the water convoy and then add water all the way, and then slowly at the end. And slowly at the end until it reaches 100. Okay. So that will be the first 100. You're going to then pour it into the flask, but you're still 250 mils of water short. So you're going to repeat this process until you get 250. So another 250 of water will go into that 500 ml flask. Another 100. And then another 100. Last part, 50 mils. Okay, 50 mils. Okay. So now I have a total of 350 mils. And because I only added 7 mils of the 50x, I have successfully diluted it into what we call 1xTAE. So let's label it. This way you won't forget what this buffer is. And then when we come back to refer to it, you actually remember, oh, right. This is the TAE buffer I made. So you're going to put this TAE 1x. Okay. And you're going to tape it and say, I'm going to remind myself, this is the 1x TAE. Let's move on to step 4. Step 4 said measure out 50 mils of 1x TAE and put it in a 250 ml flask. Okay, so this is the part we're going to do. We're going to measure out 50 mils of 1x TAE. It's a bit much, so I'm going to pour out a little bit. Okay, that looks good. Then I am going to put it in here. So then now I have 50 mils of 1xTAE. I am actually going to leave this buffer for later, and this buffer is what I'm going to take. Okay, next for step 5, we're going to weigh out 0.5 grams of agarose to make a 1% agarose solution by using 50 mils of 1x-TAE in the 50 ml flask. Well, I already have 50 mil of the 1x-TAE in my 250 ml flask. The next thing I need to do is weigh out 0.5 gram of agarose. So again, we're going to fold our weight paper into half. We're going to check that our balance have the air bubble in the center. Turn it on, and then put the paper on, hit tare. Make sure it's 0.00, it's a gram. And then now we're going to take the agarose with the spatula and weigh out 0.5 grams of this. So we're going to take a look. Oh, overshot it. Okay. Okay, and then we got 0.5 grams of the agarose. And then because we have folded it, it's going to make it really easy to dump into your flask. Okay. Once we're done, if there's any residual powders, remember to use the dustpan and the dusters to clean it so it doesn't stay on the balance and eventually it will get really gunky and hard to clean. Okay, next, after weighing out the agarose and put it into the buffer, swirl the solution. Won't all go in, but the next step, we're going to microwave it and it should all go into the solution. Now bring your flask with the agarose over to the microwave. Put it in and let it go for a minute while you watch it and make sure that it does not bubble over. So you almost have to be at an angle and look for the flask and make sure that as it bubbles, it does not bubble over. If you can see the bubbling and feel like it's going to bubble over, then make sure that you stop it and then you can resume again. Okay, after a minute of boiling, you're going to use a wet paper towel. You can find paper towel by the sink. Fold it like so. Because it's really hot, you can then reach over and then be able to hold the neck of the flask without being burnt. And then look, I am still seeing there are actually particles inside the solution. Okay, so it's not completely clear to me. I'm not sure if it's going to show up in the video. So I am going to boil another 30 seconds to ensure that it's fully dissolved. And again, watch for the fact that it does not boil over. That means if it's boiling but inside the flask, that's fine. But you just don't want the liquid to boil over outside of the flask. And right now it's all contained, so that's good. Okay. Okay, let's take another look. Okay, now to me, it looks completely clear. And I know you're seeing water dripping. That's actually from the wet towel. Okay, so to me, this is good. About 1 minute and 30 seconds of microwaving, and then it should be good. Next, we're going to let it sit on the bench and cool for about 4 minutes before you raise your hand to ask your instructor to come with the gel grain and add it in here. So the goal of the gel grain is to make the agarose stained, and when you run DNA through it, the DNA will be stained to be seen. So after about 4 minutes, your solution should still be liquid, but it is now not burning hot to touch. Raise your hand, call your instructor over to bring the gel grain. Under the instructor's guidance, you're going to pipette 3 microliters. Remember, this will be P20, dialed to 030. You're going to imagine that decimals, 03.0, and take 3 microliters. That's all there is for 3 microliters. Add it in to the solution, okay? Get rid of the tip and then swirl it. It should turn orange with the dye. And then pour it into your gel tray with the comb. And then the other group will be pouring theirs into their tray. Now that will complete step 9. After this step, make sure to go and rinse out your flask immediately so the agarose does not begin to solidify around the flask. While it is cooling, you can move on to making your DNA sample.